Hello? Is this thing on? Okay. Welcome to fermentation, also known as anaerobic respiration. All right. So, what happens during fermentation? So just to recap, glycolysis, okay, is a very ancient and universal process used by virtually every organism on Earth. And glycolysis itself is an anaerobic process. Okay. And the thing with glycolysis is at the end, it makes some ATP and makes some NADH. Okay. It also uses ATP, so it breaks it down into ADP plus PI. So that helps to recycle the ADP in order to keep making ATP. But nothing in glycolysis breaks down the NADH, so you get the NAD plus back. So what fermentation does is it does just that, and we'll see that on the next slide. Okay. Because lots of microorganisms thrive in places where oxygen is limited, or because aerobic organisms tend to, consume ATP faster than they can make it, we need to have a way to make ATP when there is no oxygen. Okay, and that's fermentation. So the main goal of fermentation is to recycle NAD+. Okay, if it recycles NAD+, then glycolysis can continue. Okay, and that's what we want, because in the absence of oxygen, okay, the only source of ATP is glycolysis. Okay, so under anaerobic conditions, so that's no oxygen, the electron transport chain does not happen. So we don't get all of that wonderful ATP from our electron transport chain. Okay, the only source of ATP in the absence of oxygen is glycolysis. Okay, if it is aerobic, right, NADH donates its electrons to the electron transport chain, and that regenerates NAD+. And that NAD+ goes back to all the places it's needed. It goes back to the Krebs cycle, it goes back to acetyl-CoA formation, and it goes back to glycolysis. Fermentation allows NAD to be recycled when oxygen is absent. Okay, it does not produce any more ATP, so we don't really, get much ATP out of it. We don't get any ATP out of it, but it is necessary to regenerate NAD+. Okay, if there were no regeneration of NAD+, glycolysis would stop. Okay, and if glycolysis would stop, there would be no more ATP. Again, this is all without oxygen. Okay, there are two types of fermentation used to regenerate NAD+, lactic acid and alcohol. And basically, the type that you do is based on what kind of organism you are. So we, as animals, do lactic acid fermentation. And you may or may not have heard your coach talk about lactic acid, that burn in your muscles when you go anaerobic. That is lactic acid. That is your cells saying, holy crap, breathe a little harder so I can get some oxygen, because right now we are limited. Okay, so let's get into lactic acid fermentation. So at the end of glycolysis, you have, of course, pyruvate. How many? Oh, I believe dose. 2 molecules of pyruvate. So If there is no oxygen, okay, those pyruvate will go into lactic acid fermentation. And of course, shockingly enough, lactic acid fermentation produces lactic acid from pyruvate. Okay, so again, this may have been something that your coach mentioned to you when you're talking about how much your muscles burn. They burn because you are now producing acid in them. So when your muscles are working hard enough to use up all the available oxygen, okay, then we still need to get glycolysis to continue. So in the absence of oxygen, they will ferment pyruvate into lactate. And this is, again, all to regenerate NAD+. We must have NAD+. And we're going to see a nice little equation in a minute. A bunch of organisms use lactic acid fermentation. Obviously, we do, humans. Bacteria that convert milk into yogurt. The acid is what kind of spoils it and makes it yogurt, has that zippy flavor. Sour cream, and of course, my favorite, cheese. Ah, cheese. I love you, cheese. I love you. Okay, so here's an example of how lactic acid fermentation works. So here we have the process of glycolysis. We take glucose and break it down into pyruvate. Okay, over the course of that process, we consume 2-NAD and produce 2-NADH. Pardon. We also are net, right? Net produce. We take 2-ADP and use the energy released in glycolysis to produce 2-ATP. I don't know why I always lose my phosphate there. Get on it, phosphate. Get up there. All right, so this is the ATP we need. So this, in the absence of oxygen, this is our only source of ATP, okay, without oxygen. So we need to keep glycolysis moving. So if you remember, in the first part of a glycolysis, okay, the energy investment, that is nearly illegible, but we're going to go with it. Glycolysis consumes 2-ATP, to produce 2-ADP. So those ADP can then be recycled back in here. So glycolysis kind of keeps itself going with the ATP, ADP side of it. However, we need to figure out a way, how am I going to get my NAD+? So in the absence of oxygen, no O2, the pyruvate are shuttled into fermentation. Okay, if you're doing lactic acid fermentation, the end product is lactate. Whoops, that was interesting. The end product is lactate. We don't really care about lactate. It really does nothing exciting. What we care about is that over the course of fermentation, some NADH are consumed as the energy to drive fermentation, and NAD+ is recycled. Hooray! Yay! And now that can feed back into glycolysis. Their arrow was totally better than mine. And keep it moving. Okay? So now everybody's happy. So that is lactic acid fermentation. So there's lactic acid fermentation in action. You bet their muscles are burning right there. In other organisms, another type of fermentation, okay, is alcohol fermentation. So many microorganisms, such as yeast, engage in alcohol fermentation. Same reactants, pyruvate, goes into alcohol fermentation in the absence of oxygen, but different products. The products are alcohol